Hi everyone, myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the eigenvalues and eigenvectors and that related problems for distinct routes. From that, I'll take the first question. Find the eigenvalues and eigenvectors of the matrix A and its inverse. Where what about A? 1, 3, 4, 0, 2, 5, 0, 0, 3. Okay, for that, what about the given matrix? This is 3 by 3 matrix. For that, find eigenvalues and eigenvectors. Already we discussed in the previous classes how we are finding eigenvalues and that correspond. Now we have to discuss with for finding that corresponding eigenvectors. Once you have to observe the given matrix is upper triangular. Their upper triangular means here below the diagonals are zeros, right? Below the diagonals are zeros means directly here without finding the eigenvalues, that corresponding diagonal elements only the eigenvalues. That corresponding diagonal elements only the eigenvalues. This is one of the property in the eigenvalues and eigenvectors. If the upper triangular matrix, upper triangular or lower triangular, for the corresponding diagonal elements only the eigenvalues. Here eigenvalues are 1, 2, 3. Okay, or else if you are not remembering that property, for that what about the general concept for finding eigenvalues? From the characteristic equation, A is given by det A minus lambda I is equal to 0. From that, what about A? 1, 3, 4, 0, 2, 5, 0, 0, 3. Okay, from that, write it as 1, 3, 4, 0, 2, 5, 0, 0, 3 minus lambda into 1, 0, 0, 0, 1, 0, 0, 0, 1 is equal to 0. From that, just subtract and multiplying with lambda, that is 1 minus lambda 3, 4, 0, 2 minus lambda 5, 0, 0, 3 minus lambda is equal to 0. For that we have to find the determinant value. If you are finding the determinant, okay, from that 1 minus lambda into 2 minus lambda into 3 minus lambda is equal to 0. From that, what about equating with the 0? Therefore, what about the eigenvalues for that? Lambda is equal to 1, 2, 3. Therefore, characteristic roots or eigenvalues are lambda is equal to 1, 2, 3. This is the general procedure for finding eigenvalues. But if you know the property of the eigenvalues or eigenvector for the below or above the diagonals are zeros, for that case directly that upper or lower triangular matrix, that corresponding diagonal elements only the eigenvalues. Here this is upper triangular, therefore directly what about the eigenvalues that are 1, 2, 3. Okay. Now here once observe these eigenvalues, one more name for the eigenvalues are latent roots or characteristic roots, that are 1, 2, 3. Once observe here the eigenvalues are distinct. Okay, now we are discussing about the distinct eigenvalues that corresponding eigenvectors. Okay, here first what about the first eigenvector? Lambda is equal to 1. Okay, from that what about the characteristic vector or corresponding eigenvector for the corresponding value of lambda is equal to 1. What about the formula for the eigenvector? Ax is equal to, or else A minus lambda I into x is equal to 0. Here what about A? Given matrix, that is 1, 3, 4, 1, 3, 4, 0, 1, 5, 0, 0, 2 minus, what about lambda value here? 1 into that corresponding I, 1, 0, 0, 0, 1, 0, 0, 0, 1 into x is equal to 0. Here what is x? What is x here? The unknown column vector of x1, x2, x3 is equal to 0, 0, 0. Okay, from that just subtract these two. 1 minus, that is 1 minus 1 is 0, 3, 4, 0, and next 1 minus 1 here 0, and there 5, and here 0, 0, 2 minus 1 as 2. Okay, that is 2. Here 0. From that here 0, 3, 4, x1, x2, x3 is equal to 0, 0, 0. Once observe there, this is, okay, after subtracting this 1 minus lambda into I into x is 0. That is 1 minus 1 is 0, 3 minus 0 is 0, 4 minus 0 is 0. And 0 minus 0, 0. And 1 minus 1 is 0. And 5 minus 1 is 5. And next 0 minus 0, 0. And 0 minus 0, 0. And 2 minus 1. That is 1 there. Here 1. Okay, na? Here 1. For that here once observe, this is the concept after getting this formula a minus lambda I into x is equal to 0. From that here 0 and 1. And from that here, once after getting this matrix reduced as echelon form for finding the unknown values of x1, x2, x3, or else directly solve, write it as the equations form and solve that too. But here directly the given matrix here, this all elements below the diagonal and diagonal some elements also 0, then write it as directly equation form. What about the equation from that? Here 3x2 plus 4x3 is equal to 0. And the second equation 5x3 is equal to 0. And the last one here, okay, from that here x3 value 0. And what about x1? We don't know that x1 value. Once observe from that second row and third row, from that we get x3 value is equal to 0. This is first equation and this is second equation. From the second equation we get directly x3 as 0. And from the first equation, if you know the x3 value, then there we have to substitute that is x2 is equal to 0. Therefore, after solving these two, we get directly x2 is 0 and x3 is 0. Here, what is missing? x1 is missing. For that, we have to assume. Let us assume one arbitrary constant, that is x1 is equal to alpha. Therefore, what about x1, x2, x3 values here? x1, x2, x3 is equal to here alpha 0, 0. These are the values of the unknown characteristic, unknown vector x1, x2 is equal to alpha 0, 0. Then here I'll take the constant, alpha outside, then 1, 0, 0 as the corresponding eigenvector if lambda is equal to 1. Therefore, once observe, then only I am writing there here, that is x is equal to alpha 0, 0, alpha 1, 0, 0. I am taking alpha outside, is the solution where alpha is a arbitrary constant, that x is equal to 1, 0, 0. Therefore, this is the corresponding eigenvector if lambda is equal to 1. Okay, similarly, what about the next eigenvalues? Lambda is equal to 2 and lambda is equal to 3. For that, we have to find the corresponding eigenvectors. And the next case, characteristic vector for the lambda is equal to 2. Characteristic vector, one more name, that is eigenvector. For the corresponding eigenvalue of lambda is equal to 2. For that case, again, what about the formula? A minus lambda I into x is equal to 0. A minus lambda I is equal to 0. Same what we explained in the previous case. Same we have to substitute there A and subtract with the lambda. Here lambda value is 2 into I is into x means there x1, x2, x3. After subtracting that, here we get directly minus 1, 3, 4, 0, 0, 5 and 0, 0, 1 into x1, x2, x3, 0, 0, 0. Again, once observe here, some values are 0, so that write it as first one, the equations form, that is minus x1 plus 3x2 plus 4x3 is equal to 0. And the second equation 0 into, once observe how we are writing that equation form, minus x1 plus 3x2 plus 4x3 is equal to 0. And what about the second equation? 0 into x1 plus 0 into x2 plus 5 into x3 is equal to 0. And from the third row is multiplied with the column, that is 0 into x1 plus 0 into x2 plus 1 into x3 is equal to 0. From that, what we are getting that equations? First equation, minus 1 x1 plus 3x2 plus 4x3 is equal to 0. Second equation, 5x3 is equal to 0. And the third equation, x3 is equal to 0. Once observe from the last equation and the second equation, directly we get x3 value is equal to 0. x3 value is equal to 0. If you know the x3 value, then we have to substitute in the first equation. We get x1 and x2? No. Why? Because here x1 is unknown and x2 is unknown. From that, okay, that means here unknowns are 2 are there, but we get only one value of x3. From that, we have to assume two values are arbitrary constant. From that, I am assuming here x2 is k and x1 is equal to, once observe, first I am taking from the equation minus x1 plus 3x2, after substituting x3 as 0, that is x1 is equal to 3x2. From that, I am assuming first x2 as k. Okay, if you are taken x2 as k from the above equation, what about x1? x1 is equal to 3k. That means here x1 is equal to 3k and x2 is equal to k. From solving the equation, from that we get directly x3 is equal to 0. Therefore, what about the eigenvector? For the corresponding eigenvalue of lambda is equal to 2, there x1 is 3k and x2 is k and x3 is equal to 0. Here I am taking k outside, that is 3 in 1, 0. 3, 1, 0. Therefore, what about the corresponding eigenvector for that? If lambda is equal to 2, for that the corresponding eigenvector is 3, 1, 0. If lambda is equal to 1, for that case, what about the eigenvector? 1, 0, 0. Similarly, we can find out the next. What about the third eigenvalue? Lambda is equal to 3. Okay, for that, again, same concept for finding the eigenvector for lambda is equal to 3. Again, apply the formula for a minus lambda I into x is equal to 0. From that, here, what is lambda value? That is a minus 3i into x is equal to 0. Here again, we have to substitute A matrix and multiplying with the 3 into identity of 3 by 3 matrix and subtracting with the 2. From directly we get, okay, that is minus 2, 3, 4 and 0, minus 1, 5 and 0, 0, 0. After solving that, directly we get 3 by 3 matrix, that is minus 2, 3, 4, 0, minus 1, 5 and 0, 0, 0. And what about capital X? There unknown column vector, that is x1, x2, x3. From that, once observe, again same concept, same as the last case. Here write it as first equation form. First row is multiplied with the first column, that is minus 2x1 plus 3x2 plus 4x3 is equal to 0. Next one, 0 into x1 minus x2 plus 5x3 is equal to 0. And the last row completely is 0. From that, here, what about the equation? That is minus 2x1 plus 3x2 plus 4x3 is equal to 0. And the second equation, minus x2 plus 5x3 is equal to 0. Once observe here, from the two equations, how we are getting x1, x2, x3 values here? Directly we did not get that x2, either x2 or x3 or x1. For that case, let us take, okay, either x1 or x2 or x3 are the arbitrary constants. In that case, from the last substitution, I am taking x3 as the arbitrary constant. x3 as the arbitrary constant. From that, okay, let us take this as the first equation and second equation. There I am assuming x3 is equal to k. Okay, x3 is equal to k. Substitute in second equation. From that, what about x2? What about x2? That is 5 into k is 0. That is x2 is equal to 5k. This is x2 is equal to 5k. Similarly, okay, now we know that x3 and x2, substitute in the first equation. Substitute x2, x3 in the first equation. From that, we get directly x1. That is minus 2x1 plus 3 into 5k plus 4 into, what about x3? K is equal to 0. From that, minus 2x1 is equal to minus 15k minus 4k, that is minus 2x1 is equal to, this is minus 19. This is minus 19. Therefore, x1 is equal to what? 19 by 2k. x1 is equal to 19 by 2k. Now we have to substitute. Then I'm substituting that x1, x2, x3 values in the given the unknown column vector, that is x1, x2, x3. Therefore here x1, x2, x3 is equal to what? First one 19 by 2k, next to 5k and k. From that, I'm taking denominator fractional values outside. From that, k by 2. I'll take k and by 2 outside. From that 19, there 10 and 2. Okay, therefore this is the eigenvector for the corresponding eigenvalue of lambda is equal to 3. Lambda is equal to 3. Therefore, if lambda is equal to 3, for that case, the corresponding eigenvector is 19, 10 and 2. And next, if lambda is equal to 2, for that case, what about the eigenvector? 3, 1, 0. If lambda is equal to 1, for that case, eigenvector 1, 0, 0. I'll write it here. If lambda is equal to 1, that corresponding eigenvector x1 is equal to 1, 0, 0. And if lambda is equal to 2, for that case, eigenvector x2 is equal to 3, 1, 0. 3, 1, 0. And if lambda is equal to 3, then that corresponding eigenvector x3 is equal to 19, 10, 2. 19, 10, 2. These are the three eigenvectors for the corresponding eigenvalues. The three eigenvalues are distinct. Okay, this is the concept for finding eigenvalues and eigenvectors. In that same questions, what they are asking, find the eigenvalues of A inverse. From one of the property, if the lambda 1, lambda 2, lambda 3 are the eigenvalues of A, and 1 by lambda 1 comma 1 by lambda 2 and 1 by lambda 3 are the eigenvalues of A inverse. This is the property for one of the property for finding eigenvalues of A inverse. If eigenvalues of A, lambda 1, lambda 2, lambda 3, for that, what about A inverse eigenvalues? That reciprocal values, that is 1 by lambda 1, 1 by lambda 2 and 1 by lambda 3. Therefore, from that property directly, what about the A inverse eigenvalues? Already we know that here. What about the eigenvalues of lambda there? Lambda is equal to 1, 2, 3 for the eigenvalues of A. Therefore, A inverse eigenvalues are 1 by lambda 1, comma 1 by lambda 2, comma 1 by lambda 3. That is 1 by 1, comma 1 by 2, comma 1 by 3. Therefore, these are the eigenvalues for the A inverse. Okay, for this question, we discussed for finding eigenvalues and the eigenvectors, and after that we are finding A inverse. Okay, this is this question for finding eigenvalues and that corresponding eigenvectors for the distinct eigenvalues. Okay, next class we will discuss with the same concept with the similar eigenvalues. Okay, this is the concept. Okay, thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.